Okay, so we got to this point in class today where we drew our triangle, and we said that the x value of one of the legs of the triangle had to be the same as the y value, so we called them both x's. And then because this is the radius of the circle, we said that the length of this part of the triangle, the diagonal part, had to be equal to 1. So number 4 says label each length and angle measure. We did that. What kind of triangle do you have? Well, because we have a 90 degrees right here, one of the kind of triangles that we have is a right triangle. That's actually very important. So we have a right triangle. But we actually have a more specific than right triangle as well. You have two sides that are the same. So when you have two sides that are the same on a triangle, what is that called? It's an isosceles triangle. So you'll also have what's called a right isosceles triangle. And so this is also going to be important in just a minute as well. Number 5, what formula can you use to find the lengths of the unknown sides? So I want to know what this x is and this x is. I think it's around 0.75-ish, but I want to know the exact value, not the approximate value. So what formula can we use? Because this is a right triangle, we can use the Pythagorean theorem. And then it says to calculate the lengths and label your triangle sides with these values. So the Pythagorean theorem on a right triangle says that a squared plus b squared equals c squared. In this particular triangle, the c is going to be the hypotenuse, the one across from the right angle. So c squared then will be 1 squared. The other two legs don't matter whether they're a or b, but because they're the same anyway, we're going to write down x squared plus x squared. From here we can solve. X squared plus x squared is 2x squared equal to 1. We'll divide both sides by 2, so x squared equals 1/2. We'll take the square root of both sides. Don't forget to include your plus or minus 1/2. So we have that x is equal to the positive version and the negative version of the square root of 1/2. I'm going to go ahead and simplify this by putting the square root at the top. Square root of 1 is 1. And the square root of 2, I'm going to leave as the square root of 2. So I now have plus or minus 1/√2. If I simplify this further by rationalizing the denominator, I would multiply both top and bottom by √2/√2. And so now I have the rationalized or simplified version as √2/2 plus or minus. So what that means is that the label that I would put here is going to be √2/2. And then this side length of my triangle is going to be √2/2. Well, because this is the same as the x value for my point, and this is the same as the y value for my point, I now know the exact value that lands on this point, not just the approximation. It is √2/2. Now, number 6, it says use the lengths of the triangle to write the exact point. Here is your exact point. The red is my approximated point. Okay? We're going to move to the next part of this. The next question then. I am going to move down to number 8. I'll skip number 7 for right now. I'll come back to it in class tomorrow. Number 8, it says, what is the exact value of the sine, cosine, and tangent of this special angle? Because I was able to find these x and y values, I no longer need this approximation. Earlier I said that the cosine of 45 degrees using an approximation was approximately 0.75. However, now number 8 is asking me what is the exact value. So I would now write that the cosine of 45 degrees is equal to the x value here in this case is √2/2. And then the sine of 45 degrees would be the y value. So again, √2/2. And then the tangent would be the y value divided by the x value, √2/2 divided by √2/2, which would produce 1. So number 8, you can now fill in your parts there. So I would like you now to go into your calculator and type in the cosine of 45 degrees. When you hit enter, notice what it says. Please pause the video at this point. You will notice that the cosine of 45 degrees in your calculator will come out to be square root of 2/2. If you do the cosine, you will still get square root of 2/2, and the sine is going to be 1. Now, if you do Control Enter at this point to figure out what the approximate value of the cosine of 45 degrees is, the calculator will tell you it's about 0.70. Our approximation we got earlier was 0.75. So we were pretty close with our approximation 0.75, but we were able to use the Pythagorean theorem in this right triangle to come up with the exact value, and this is the value that your calculator produces. Oh, how magical. Oh, I would have been wearing my magic hat at this point in class, by the way. And that is it for this part. I'll finish the rest in class tomorrow.